Welcome to my Switching, Routing, and Wireless Essentials course. This should be the CCNA version 7 curriculum. This is the second of 3 courses. So electing a root port from multiple equal cost paths. Again, we always look at that lowest bid. We always look for the lowest priority. And if we're talking which port should be the appropriate port, it will be the lowest sending port ID. So if we have equal ports, whatever is going to be the lowest port number, that will be the root port. For example, here we have where this is going to be the lowest sending bid. We have elected S1 as our root bridge. Ports going away from the root bridge are designated ports. Ports that are going towards the switch, the root bridge, will be our root ports. So switch 3, F1, switch 4, F3, those are our root ports. On S2, whichever is the lowest port, that will let us know which one will become our root port, and the other port connected will become our alternate or our blocking port. F1 is lower than F2, so F1 becomes our root port. So what happens if we have a lowest sending port priority? What happens when we have 2 switches connected? Which one will be the sending priority? Here we have one that actually has a bridge ID priority that was modified. So here we have 24577. This lets us know that switch 1 will actually have our root bridge that will transition on switch 1, F01 and F02 to designating ports. Again, the lowest sending port priority will actually be the one that stays connected. Sorry, since we have 2 ports on switch 4, the lowest one is actually going to be change to our alternate port. Because both ports are connected to the same switch, the sender's bid is equal. So the first step is a tie. So the next will be the port priority. The port priority is 128. So both ports on the switch 1 have the same port priority. So it's also a tie. However, if either of the ports on switch 1 were configured with a lower priority, S4 would be put in the adjacent port in a forwarding state. So, F01 is the lower of the 2. So that means the adjacent port, F06, should be receiving our root ports. And our F05 will become our alternate port. If we're looking at the lowest sending port ID, the last tiebreaker, if everything else is equal, the lowest sender port ID, basically from switch 4, it will connect to switch 1's F01 and switch 1's F02. The decision is based on the sender's port ID, not the receiver's port ID. So again, the root bridge is the sender. Since it was sent on F01, that is the lower of the 2. That means the receiver will put that as a root port. So let's talk about convergence time. We turn a switch on, we have STP enabled. What happens? Well, the switch actually has to go through the selection process. So STP actually has the convergence requirements. It actually has to elect its root bridge, and that takes time. So there are 3 timers that come into play. We have a hello timer, a forward delay timer, and a max age timer. all of these can be modified. The hello timer basically is the hello time is the interval between the BPDUs, and by default it's 2 seconds. But you can modify it between 1 and 10. The forward delay timer is basically the forward delay is the time that is spent listening and learning. The default is 15 seconds. And you can modify that between 4 and 30 seconds. Lastly is the max age timer, and this is the maximum length of time that a switch waits before attempting to change the STP topology. The default is 20 seconds, but it can be modified between 6 and 40 seconds. Basically, the switch can, when it comes on, it has to listen, it has to learn, it has to decide what states to be putting the different ports in. So what ends up happening is when the switch power is on, it goes into an immediate blocking state. No PPDUs will be received, and this will happen for about 20 seconds. It will transition to a listening state. Basically, the forward delay is 15 seconds. If a link does come up, the link actually is in a blocking state, and then it will transition to a listening state. From the listening state, it will transition to a learning state, which will forward the information accordingly for about 15 seconds. Then it will actually start transitioning to a forward state. The important part here is how information is modified. In a blocking state, it can only receive BPDUs, no MAC addresses, and there are no forwarding of data frames. As it transitions to a listening state, it will send and receive BPDUs, but it will not update its MAC address table, nor will it forward data frames. From the listening state, it will transition to a learning state. Here we're still sending and receiving BPDUs, and now for the first time, we start actually updating our MAC address table. We will not forward data just yet. We're just updating content. From our learning state, we will transition to a forwarding state. The forwarding state will send and receive. It will also update the MAC address table, but this is actually going to be when it starts forwarding data. So when you turn on a switch, it can take almost 60 seconds for the switch to start forwarding data. And this is the reason why. We can have STP on a per VLAN basis. We can have it as a per entire environment or per VLAN. It just kind of depends. If we're doing this per VLAN, it will be called PVST. This is just a variation of STP. So now let's talk about the evolution of STP, because there are multiple versions. One of the more complex versions of spanning tree is MSTP, way outside the scope of this exam. But we also have what's called Rapid Spanning Tree Protocol, RSTP. The latest IEEE documentation on STP basically says STP has now been superseded by the Rapid Spanning Tree Protocol. So the IEEE uses STP to refer to the original implementation of spanning tree and RSTP. So the nice thing is STP is all the variations of STP. The nice thing is we have a hybrid called per VLAN spanning tree plus. That is the default variation of spanning tree protocol used on Cisco equipment. And this actually incorporates many of the specifications of the original IEEE 802.1d, including things like alternating ports and a place to form a non-designated port, things of that nature. So it actually allows us to deal with the rapid spanning tree protocol without having to enable it, because per VLAN STP Plus actually incorporates some of those technologies. A variation sheet of all the different types of STP. PVST Plus is the default. MST or MSTP are way outside the scope of the CCNA exam. Rapid spanning tree is a newer version of STP and is referred to as 802.1W. So let's go ahead and look at RSTP, also known as 802.1W. This actually superseded the original STP, 802.1D, but it retains backwards compatibility, and it has some of the additional advantages, such as increasing the speed of recalculation of a downed link. RSTP can achieve much faster convergence when it's properly configured, and we're talking milliseconds instead of seconds, so way faster. So we actually have what's called rapid PVST. This is the Cisco implementation of RSTP on a per VLAN basis. Basically, it's RPVST plus, and it's an independent instance of RSTP. And the important part here is, for RSTP, it has to be ran on a per VLAN basis. All of this is not really capable of being ran in Packet Tracer. STP does not work very well in Packet Tracer. So STP versus RSTP, when we're talking about the different states of the ports, when we actually have operational status, we have our disable, our blocking, our listening. Well, in RSTP, all of those are discarding. Only learning and forwarding line up. When we're talking ports, we do the exact same types of ports. STP and RSTP both have root ports, designated ports, and variations of blocking ports. We can have a backup or alternate port with RSTP. And again, RSTP can also be done per VLAN. So we can actually have an alternate port and a backup port that provides us some failover options. So now let's talk about port fast and BPDU guard. What happens when you know the device connected to a switch port is not another switch, so it should not have to worry about listening for BPDUs? Well, that's what port fast does. Basically, it says this is going to be an access port and only in devices will connect to it. So do not do the operational states of STP. It will also never receive a BPDU because, well, only in devices should connect to it. Alternates to STP are things like RSTP and MSTP. Layer 3 routing allows for redundant paths and loops in topologies without blocking ports. But when we're talking layer 2, there's only so many options. Questions, concerns, please reach out. Thank you.